Eccentric footing design to BS8110 in Tekla tags. In my previous video, I showed you how to do eccentric footing to ACI 380. This video will focus on how to do it to BS8110. So that is to Euro codes. That is according to Euro code. So I just click new. Good. First, we need to change the locale to United Kingdom. Click new. Go to foundation, then I go to foundation, analysis and design. I go to foundation, analysis and design to Eurocode, stroke BS8110. This is a pad footing, not you can change to strip, but this is a pad footing. Change to 2000 by 2000, footing depth 600. Then soil property, I can add a column. My column should be that 300 by 300. That is okay. Then I will add axial load of about how many kilonewtons? Let's say 350 kilonewtons. That is axial. And then imposed 250. Then click OK. Go to design options. Density of concrete is that. A national annex is United Kingdom. And then we can now preview results. Now this is isolated. We need to change it to eccentric because my column has a length of 300. I want this column to come at this position. Now the position in x direction will be 300 divided by 2, that is 150. Then click OK. So this one has failed, but we need to see if maybe the reason for failure is we have only used bottom reinforcement, because this size of column of 2000 or 2 meters by 2 meters is enough, and a depth of 6 millimeters, 600 millimeters is enough. So let me go and check the reinforcement. Maybe we need to add top reinforcement in both x and y direction. So we can just calculate again. Go to next. Okay, now I will change my concrete class to this class 25. We need top reinforcement. We need to change this to spacing of 150. That is, reinforcement is x direction. Is failing in utilization, that is x and y. Okay. So I can increase this to 150. And the spacing here reduced to 150. Similarly, I can increase the diameter because this one is failing. Okay, that is top. Bottom is okay. Now this one will just be 200. I will again the top here be 150. We can increase this to T16. Increase this one to T16. Okay. Remember, design sometimes is try and error. Now take it back to that, because the problem was the bottom rebar in the right direction. We use this to 150. This one should be again. Let's try it all off if it's going to pass, because it is very rare to see someone using T16 unless it's a high almost G+4. So this one again, because of consistency, I need to change from 200 to 150. Don't need to confuse people on site. They may confuse this, and their house will end up collapsing. We can try, because sometimes class 25 is not achievable on site. Let's try class 20. Class 20 is still passing, then 460. Sometimes that class is not very achievable on site because they're not going to use it. Then I'm going to click finish. Okay, this one base pressure is failing. Base pressure is failing in base pressure. So let's go back to calculate. This one has failed. Okay, we need to go back. Soil property. We change this on the soil bearing to 200. Okay, about 200 kilonewton per meter. The allowable bearing pressure. Let's see. Instead of saying for this to calculate automatic, if it's going to pass. Calculate. Let's try to increase this one to 2400 by 2400. $2,500 by 2,500. Then finish. But if you can notice that the foundation, for example, assuming it was a perimeter wall, the column should be right at the edge. Because maybe the wall of this building is at the perimeter wall, right? So we need to make sure that the position is just 150. Here 150. Half of this length. Change this one to 16. 16. 16. 16. We want to see if this one is going to change something. I'm going to use class 25. Then if you go back, length of foundation, that's 3 meters. By 3 meters. Now that one has passed. Then next and then finish. But before we finish, you just need to change this bar to T12, class 20, twelve. Now because 12 is failing at 150, I just need to use the 16 at 200. And then because I need consistency, use the 16 at 200 all through. One should be 200, not less. $200. All right. Nominal cover to foundation. We use 50, 50, 50. I'm not sure about crack width, but this is just a demonstration. You need to go and do your good research. I'm not sure we do crack. We check for crack width in footing. Huh? I'm not sure of that. So next and then finish. So that's all for me today. Thanks for watching. I will see you in my next video.